97, we have the concept of rationalizing a binomial denominator. And in particular, I'd like to do number 8, if I could, page 98 actually. I'd like to do number 8, which says 12 divided by 4 minus 2 square root of 3. Now, because it has a binomial denominator, we're going to have to use a different approach to rationalize the denominator. Remember, rationalizing a denominator means to eliminate the radicals from the denominator. And if you were to multiply the numerator and denominator by the square root of 3, that would not eliminate the radical from the denominator. By trying a few things, you're going to find that if you multiply the denominator by exactly the same thing as the denominator, but with the opposite sign in the middle, that is, if this is 4 minus 2 square root of 3, we're going to multiply by 4 plus 2 square root of 3. That's called the conjugate of the denominator. Anytime you take the negative of this middle term, it's called the conjugate. Multiply the numerator and denominator by 4 plus 2 square root of 3. Now, some people are inclined to multiply the numerator, 12, times this binomial, but sometimes that's appropriate, but in this case it's better to just leave it in a factored form for the numerator until you can multiply the denominator and see what it looks like. So let's multiply out the denominator. Let's take the denominator, 4 times 4. Remember, this is FOIL. 4 times 4 would be what? 16. And then the outer times outer. The outer times outer would be 8 plus 8 square root of 3. The inner times inner would be minus 8 square root of 3. And you see what happens there? That subtracts out. That's what makes this conjugate work. The fact that the middle term subtracts out, and then the last times last would be negative 4, and then the square root of 3 times the square root of 3 would be square root of 9, which is 3. Can we just put 3? All right, don't put the square root of 3. That's a very common mistake. People take the square root of 3 times the square root of 3 and put the square root of 3. It's got to be the square root of 9 or just 3. Now, in the meantime, the numerator is staying 12 times the quantity of 4 plus 2 square root of 3. Okay? All right, now, for the next step, simplify the denominator. And you'll have 16 minus 12. 16 minus 12 is just 4. So the denominator is 4. And the numerator is 12 times 4 plus 2 square root of 3. Like that. Now what happens? Because this 12 is in a product, 12 times this quantity. 12 is a factor of the entire numerator. So can you divide out the 4? Yes. Divide out the 4. In other words, 4 goes into 12 3 times, and you get an answer that says 3 times the quantity of 4 plus 2 square root of 3. All right? Now, when you check the answer in the back, you won't find that answer there. There are 2 other answers that are slightly preferred compared to this. One answer would be if you want to distribute this 3, and that would give you, what, a total of 12 plus 6 square root of 3. Okay? That would be a good answer. That's the multiplied out form. Or you could have factored out a 6 from this multiplied out form. You could have factored a 6, and that would leave 6 times 2 plus the square root of 3. Now, the truth be known, all 3 of those answers are equally correct, although I think these 2 are preferred. These 2 answers are the preferred answers. That's why I put those in the back of the book, although this is also correct. Is there any question on that? Okay. All right. Now, I'd like to look at number 10 on the next page. Number 10. Number 10, the problem says the square root of 27 divided by the square root of 6 minus the square root of 3. All right? So our first step would be to determine the conjugate of the denominator. The conjugate of this denominator would be what? square root of 6 plus the square root of 3. So you'll multiply the numerator and denominator by the square root of 6 plus the square root of 3, right? Now, in this case, you can simplify the square root of 27. So I think it might be helpful to simplify that square root of 27. Remember what that would be?
3.
All right, that would be like 9 times 3. So it would actually be 3 times the square root of 3. 3 times the square root of 3. And it will also have this square root of 6 plus the square root of 3. And then the denominator, when you multiply this out, let's FOIL. First times first. Now what's radical 6 times radical 6? Radical 36, or 6. And then the outer times outer, and the inner times inner. Outer times outer would be radical plus radical 18 minus radical 18, which subtracts out, doesn't it?
Yeah.
Okay, that's good. Subtracts out. And then the last times last is a negative times a positive is a negative 3. Okay? Negative 3. Okay? Now, another thought that you might have is, should I multiply out this numerator? Or should I leave it in a factored form? And I'd say, well, let's not be in a hurry to multiply it out. Let's leave it factored. If we want to multiply it out, you can do that later. It might help to leave it in a factored form. It really might. So let's see. The denominator simplifies to 6 minus 3, which is 3. The numerator is 3 square root of 3 times the quantity of the square root of 6 plus the square root of 3. Now, you see why we didn't multiply it out? Because you've got a 3 that divides. Because this is in a factored form, you can divide out the 3. So this 3 divides out, and what's left is radical 3 times radical 6 plus radical 3. Let's go ahead and multiply that out and see what it comes out. That would be the square root of 18, and then what? Radical 18 plus square root of 9, which is 3. So we got radical 18 for the first, and we got 3 for the second. Okay? Can you simplify radical 18? Can you simplify radical 18? What would that be? 9 times 2. Right? Well, it's 9 times 2 inside the radical. All right? And then it's 3 times the radical 2, and then plus 3 for the final answer. Is that the answer in the back, I hope? Okay. Is there anything else you could do?
Yes.
You could make it, you could factor out the 3 if you wanted to, although it's not required. You could factor out the 3 and you'd have 3 times the quantity of radical 2 plus 1. Okay? Any questions on that? Okay? All right. As another example from this page, I would like to look at number 15. Number 15 is a sample of a problem in which you have a binomial numerator and a binomial denominator. 3 plus the square root of 3 divided by 3 plus the square root of 6. So what would be the conjugate of that denominator?
3
All right? 3 minus the square root of 6, right? The same as the denominator, but with the opposite sign. Because this is a plus, we're going to make this minus. And then, of course, whatever you multiply the denominator by, you have to multiply the numerator by it also. Okay? Now, I'll tell you what, in this problem, you're going to have to multiply both of them out. You're going to have to multiply both of them out. But I still like multiplying the denominator out first because that's the fun part. That's the part that's going to work out even. So let's do the first times first, which in the denominator, which would be 3 times 3 is 9. And then the outer times outer, and the inner times inner. Do I even need to write that down? After you do a few of these, you see it's going to subtract out anyway, so you don't need to write it down. When you're doing a product of a number, of a quantity, and its conjugate, the middle term always subtracts out. That's the nature of this beast. Then we'll do the last times last, which would be minus 6. Okay? So the whole denominator is just 3. Isn't that nice? What about the numerator? Numerator is going to be as ugly as the denominator is nice. So let's just go ahead and start with it. The numerator is going to be the first times first is 9. Outer times outer is, now this 3 is outside the radical. So now this is going to be a tricky question. This is going to be like, who is buried in Grant's tomb? What is 3 times the square root of 6? 3 times the square root of 6. That's hard, isn't it? And what's a positive times a negative would be? Negative. So the answer I want is negative 3 square root of 6. Then for the inner times inner, I get what? Plus 3 square root of 3. Okay? Any question there? And question?
You lost me. What did you get the I thought it was just 9.
All right. Well, see, this is not square root of 3. See, this is not square root of 3. This is 3. So 3 times the square root of 3 would be 3 square root of 3. Okay? Now, when you do the last times last, that's where you have a square root times a square root. You have to really pay attention to whether these are square roots or whether they're not square roots. You know, whether they're square roots or whether they're regular numbers. Watch out for that. That'll get you every time. Now we're going to do the last times last, which is a positive times a negative, which is negative. Square root of 18. Okay? All right, now we've got the denominator all simplified as being 3, don't we? So that's going to be 3 for a denominator. Now, the numerator. Do you see anything you can simplify or combine together?
Yes.
These two middle terms?
No.
Square root of 18.
Square root of 18. Okay, what can you do with it? You can simplify the square root of 18, can't you? What would you have to do with that? Make it like 9 times 2 inside the radical, which would give you a 3 radical 2. Let me write this all down then. I've got a total of 9 minus 3 square root of 6 plus 3 square root of 3 minus, now for the last part here, it's going to be minus 3 times the square root of 2. Can you divide out a 3 with the 9? No. No. What do you have to do before you can reduce a fraction? Factor it. Or I might mention there's one other thing you can do. You can divide 3 into each, split this up and make 4 separate fractions out of it and divide 3 in each place. But let's play it the safe way. This is not the only way, but you can factor out a 3, factor out the 3, and then what's left in the parentheses will be a 3, and then a minus the square root of 6, plus the square root of 3, and then minus the square root of 2. When you factor out the 3, that's what you get. And then it's all divided by 3. Okay, all over 3. And now the 3 divides out. So divide out the 3, and you have left just this 1, 2, 3, 4 terms. And none of those are like, are they? So the final answer would be just that. 3 minus the square root of 6 plus the square root of 3 minus the square root of 2. Nothing combines together. Sometimes they don't combine. Any questions on
Why
that?
can't you do that? On the other one you did, just went ahead and reduced it. Like on number 11, on page 99, you know how you did right
Okay.
there, the 2 and the
All right.
15? Or the 15, 30 and 2?
Okay.
And then factor that out.
Well,
Why
I
can't you do
can,
it on this problem?
I can reduce it by dividing out the 3 in the same way. See, I divided out the 3, but there's no radical times that.
Okay.
See, what I get for an answer is just this. 3 minus the square root of 6 plus the square root of 3 minus the square root of 2, and none of those are like terms. So nothing
You
combines
still
together.
get the same thing, right? I mean, if you went ahead and divided 3 into 9, you get
Oh yes,
3.
that's right.
I mean,
That's right. You can divide 3 into each of these.
Yeah.
That's what I said you could do. And you'll get that same answer. Yes.
Sorry.
Yes. There are 2 different ways to do this. I took the safe way. There's another way also that you're talking about. Okay? Any question on that? All right. Now, on the next page, we have another topic called fractional exponents. Fractional exponents. Did everybody bring their calculator today? I hope, because we're going to need the calculators. We're going to need the calculators, and you're going to need this calculator also. The one between your ears and also the one in your hand.